Hey friends, so we're gonna learn now how to aggregate your data using 5 different window aggregate functions. We have the count, sum, average, min, max, and as usual, first we have to understand the concept behind them. After that, we're gonna talk about the syntax and we're gonna cover the most important use cases that I collected from my real life projects. So now first, let's understand why they call them aggregate functions. So let's go. Okay guys, let's say that in our data we have the following informations. We have the months and the sales. Now if you apply any aggregate functions in SQL, what can happen? SQL gonna go through all rows of the window or the entire data and start aggregating the data. So that means in the result, in the output, SQL gonna give you one single aggregated value. SQL gonna go and summarize all those values, and in the output you're gonna find, for example here, the total sales. It's gonna be 175, or you can use the average or count the data and so on. So the aggregate functions gonna deliver at the end one aggregated value for a window or for the entire data. Okay, so now let's have a quick overview of the syntax of all aggregate functions. Most of them follow the same rule. So first, as usual, we have to define the function name, and in this example we have the average. Then to the next part, we have to define inside it as well the expression. We cannot leave it empty. So here we are using the sales, and the second rule for all functions beside the count, the data type of this field should be a number. And this of course makes sense, right? So we cannot find the average of the first name of customers or something like that. So we have to define a number. Then next we have to define the frame. So we have the partition by, and it is optional. So you could use it or leave it, depends. And then the next one we have the order by. It is as well optional. It is not a must or required. So you could use it or leave it. That means the whole definition of the window could be empty for the aggregate functions. Let's have a look to all functions. So we have the count, sum, average, min, max, and as you can see, only the count accepts all data types as an expression or arguments. All others require you to have a number as a data type. And for all functions, the partition by is optional, the same for order by and frame. So everything is optional over here. So now what we're going to do is that we're going to go and deep dive into each of those functions in order to understand how they work, what are the use cases, and of course we're going to practice in SQL. So we're going to start with the first one, with the function count. Hey friends, if you are new here, welcome. My name is Bara and I lead data projects in big companies like Mercedes-Benz, and I'm here to share my knowledge and best practices about data in high quality videos in this YouTube channel. So if you don't want to miss anything, make sure to subscribe. Now let's go back to the video. Okay, so what is the count function? It's really simple. It's gonna return the number of rows within each window. So it's gonna help you to understand how many rows do you have within each subset of data. So now let's go and understand how SQL works with this function. All right, guys, so now we have again this very simple example for the orders, and we have the following informations. We have the products and sales. And now we want to solve a very simple task. How many orders do we have within each product? So in order to solve it, we can use the function count like the following. So we can say count, and then we pass for it an argument or expression, the star. So with that, we are telling SQL, go and count how many rows do we have in our table. But we have a window definition like this over partition by products. So now what SQL gonna do? We're gonna go and divide the data sets into 2 partitions. We're gonna have one partition for the caps and another one for the gloves. So with that, SQL prepared our data into windows and we are ready to do aggregations. So how many rows do we have within each window? It's gonna be 3. So for this window, it's gonna be 3 rows. And as well for the next window, we have as well 3 rows. So we can have 3, 3, and 3. It's very simple, right guys? We are just finding the number of rows within each window. But now with the aggregate functions, we have to be very careful with the null values. For the count star, as you can see over here, we are not specifying anything about the sales. So we are just saying, find me the number of rows. So that means SQL will just count the nulls as 1 row. So that means if we are using the star as an argument for the function count, the null will not affect anything. So whether we have nulls or not, we are just counting how many rows do we have inside our data. But in some scenarios, we should be ignoring the nulls in our count. For example, let's say that I would like to count how many sales do we have within each product. That means if we have nulls, it should not be counted. So now in order to achieve this task, what we're gonna do, we're gonna use, instead of a star over here, we're gonna have the field sales. So now with this, we are telling SQL, don't just count blindly how many rows do we have within each window. You should be very careful with the values. Find how many sales do we have within each window. So now let's see what can happen. For the first window, we have 3 sales, so we have 3 values. So the number of rows is correct. But for the next one, how many sales do we have? We have 2. So we have this sale and then the 70, but the last one is null, so it will not be counted. It will be ignored. That's why we're going to get in the output the value 2. We have 2 sales. So as you can see, the result did change and we are now more sensitive to the null values. So be careful what you are specifying for the count. If you are using a column name like this, it will ignore the nulls. But if you have a star, it's just going to go and find how many rows do we have within each partition. Okay, so now if you go and compare the results side by side, you can see that if you specify a column within the count function, it's going to be sensitive with the nulls. So it's going to ignore it and will not use it within the aggregations. That's why we have here only 2 rows. But if you go and use the star within the count function, what's going to happen? SQL just going to go and count it. So we're going to find the number of rows that we have inside our table. And there is one more way in order to do the same thing here on the left side. You can use, instead of star, you can use a 1. So you might find it somewhere that people are using count 1 and then the same window function, and we will get exactly the same results. So the nulls will be counted and will not be ignored. So now you might ask me, which one should I use, the 1 or the star? Well, I would say it doesn't matter, right? We are getting the same results, and if you are thinking about the performance, I hardly find any differences between them. So you can go and try both of them and stick with the one that is giving you like more better performance. Now we have special case for the count function compared to all other aggregate functions. It allows any data type. So that means we can use numbers, we can use characters, dates, and so on. So that means we can go and specify something like the product for the count instead of sales. So we can go over here and say products, and it's going to go and count how many rows do we have for the products. So it's going to be 3 over here, and since here we don't have any nulls, it's going to go and count it like this. So we have 3 rows. And be careful here, we are not counting the unique rows, we are just counting the rows that we have inside our data. So this will not be counted as 1, and this as well will not be 1. So we have 3 times the caps, that's why we have here 3. Okay, so now we have this very simple example. Find the total number of orders. This is very simple task in order to find how many rows, how many records do we have inside the table orders. So let's go and solve it. So let's start by selecting just star from the table orders without anything like this. So as you can see, we have 10 orders. It's very simple, it's very easy as well. But now let's say that you have thousands or millions of rows. You cannot do it like this by just checking the rows. What you're gonna do, you're gonna go and use the function count. So we can go over here and say counts star, and then let's give it a name, total orders. So let's go and execute it. So now as you can see, we got only 1 record, 1 value. We don't see any other details. We got the 10 orders. So this is the total number of orders. This is very helpful in order to understand the content of your data. So this we call it overall analysis, or let's say having the big numbers about your business. For example, how many orders do we have, how many customers, products, employees, and so on. So having those big numbers can help us to track our business, to understand how well we are doing with the orders and with the customers and so on. So this is the basics of reporting. Now let's go and extend our task by saying provide details such as the order ID and the order dates. So let's go and do that. So select order ID, order dates, and now of course we cannot do it like this, so let me just execute it. We will get an error because here we have different level of details in our select. So in order to solve this, what we're gonna do, we're gonna use the over clause, and with that we are telling SQL this is a window function. So now let's go and execute it. So with that, you can see with that we have solved the task. We have details, we have the order ID or the dates. So this is the highest level of details since we have the order ID, and as well we have the highest level of aggregations. We have the total number of orders in the entire table orders. So now let's keep going and add more stuff to our task. Let's say that we want to find the total number of orders, but for each customers. So that means this time we have to go and divide our data by the customers. So let's go and do that. We're going to use as well a window function. So count star over, we have to divide the data using partition by, and we're going to use the field customer ID. So let's call it orders by customers, and I would like to see as well the customer informations in the query. That's why I'm gonna go and add it. All right, so that's all. Let's go and execute it. Now, as we learned before, that SQL first gonna go and divide the data. So that means we have 4 customers. We're gonna get 4 windows. The first window gonna be for the customer ID number 1, and as you can see, we have 3 rows. That's why we have here 3 orders. And the same thing for the customer 2. We have 3 orders. Customer 3, 3 orders, but only the last customer, the customer ID number 4, we have only 1 row and 1 order. So now if you go and look to the total orders and the orders by customers, you can see now we are not doing the overall analysis. We are doing like comparison between different categories. And of course, in this example, the category is the customers. And with that, we can understand as well the behavior of our customers. So you can see that we have 3 customers that has exactly the same amount of orders. So they are very similar, but we have one extreme, which is the customer ID number 4. This customer has only 1 order. So this is the only customer that has different behavior than all other customers. So you see, with very simple query, we are able now to analyze our business and understand the behavior of our customers. So if you divide the data by partition by and using count, you can go and now compare stuff together. All right, so now let's keep moving. Next, we're going to understand the special cases that we have with the function count. So now we have this very simple task. It says find the total number of customers, and additionally we have to provide all customers details. So I think it's very easy to solve. What we're gonna do, we're gonna go and select star, since we need all details from customers, from sales customers. So let's just have a look. So we have 5 customers, and the function is count star over, and we don't have to divide the data since we have to find the total number of customers for the entire table, and it's going to be total customers. So nothing new. That's it. We have 5 customers. And now, as we learned before, if you are passing the star to the count function, what you are telling to SQL is that just go and count how many rows do we have inside the table customers. So SQL just going to go and start counting, and it's going to say we have 5 customers, 5 rows. So it doesn't matter whether we have nulls inside our data, like in the last name or the score. It's just going to count the number of rows. So now let's say that we have the following task. It's going to say find the total number of scores for customers. So what do we need with this task is to find out how many scores inside our data. So as you can see, we have around 4 scores, but the last customer doesn't have any score. So we have it as a null. So the result should be 4. We cannot go now and use the star for it, because we're going to get 5. We have to go and count the scores. So let's see how we're going to do that. We're going to count as well, but this time the score, and the definition of the window going to be empty. So total scores, and let's go and execute this. So now we can see in the results we got 4 scores, which is very correct because SQL did ignore the null, and SQL now focusing only on 1 column. So focusing on those values, the nulls will not be counted. This is really great in order to check the quality of your data. So let's say that you are not expecting any nulls inside your data. So instead of going manually through the whole records, what you can do, you can go and find the total number of customers like this, and then you can go and count the total number of scores, and you can see there is a difference. So by just checking the data, I can say, you know what, we have 1 null without checking every record in our data. So with that, we can check the quality of our data and understand very quickly how many nulls do we have in the field score. And you can do the same stuff, for example, for the first name. Show it to you. So I'm just going to go and copy this, and let's say first name, or let's say country, actually. So I will go with the country. So let's go with the country, total countries. So let's go and execute this. So now if you check the result, you can see we have 5 rows with the country. So SQL gonna go and focus on the countries, and it will not find any nulls. So we have here complete data. We don't have any nulls because the total number of customers is equal to the total number of values within the country. And I can immediately find, okay, the data quality of the country is very good. All right, so now one more thing about the count function that we have learned before. We can use either star or 1 in order to count how many rows do we have. So let's just try it. I'm just going to go and duplicate it, and instead of having a star, let's have 1. Just going to give it a name. Here it's going to be 1, and you are star. So let's go and execute it. So now if you check the output, we got exactly identical results. So there is no difference between those 2 queries. It's up to you. You can try it and check the performance. I usually go with the star instead of 1. Okay, so now we're going to talk about a very important use case for the SQL window function count that I frequently use in my real projects. The data that we use for data analysis has usually bad data quality. And if we don't find those data quality issues and we don't clean it before doing the analysis, what's gonna happen? We're gonna deliver bad results, bad analysis, which can lead to bad decisions. And one very common data quality issue that you might encounter in your project or on your data is that having duplicates. Duplicates are really bad for doing data analysis. So now in order to discover, or let's say identify the duplicates in our data, we can go and use the SQL window function count. So now let's go and have some examples. Okay, so now the task says, check whether the table orders contains any duplicate rows. So how are we gonna do that? By checking now the table orders over here, we can see that there are many orders, but how to find out the duplicates? Well, the first step is to understand what is the primary key of the table orders. So what we usually do, we go and check the data model, if there is one. So for example, for this course, we have the following data model, and we can see that it is defined that the order ID is the primary key for the orders. The product ID is primary key for the products. So that means for our table, the orders, we have the order ID as the primary key, and it should be unique. It should not contain any duplicates. So now let's go to our data and check the order ID. By just looking at the data, you can see that we don't have any duplicates, right? All of them are unique. So we have 1, 2, 3, 4, and so on. But of course, in real projects, you cannot do it like this. You have to go and build a query in order to find out whether the primary key is unique. But now you might say the primary keys are usually unique because we can define it in the DDL, in the rules of building the table. Well, that's true. If you have it like this, then you don't have to find any duplicates. But usually in data analysis, we export a lot of files and a lot of data inside an extra database, and we don't build such a rules. So now in order to check the quality of the primary keys that you get from the source, we can use the count function. So let's go and build it. I'm just gonna select the order ID first as a detail, and now we're gonna do the following. So count and then star, and let's go and define the window. So it's gonna be partitioned by, and here the field gonna be the primary key. So the order ID. I'm checking now the quality of this field. This should not contain any duplicates. And now we're gonna go and give it a name, check primary key. So now my expectation is that the result of this should be at maximum 1. That means we have 1 row for each primary key, and that means as well it is unique. So if we get anything more than 1, then it means we have duplicates. Let's go and run the query, and as you can see in the results, we get for each primary key 1. So that's great. That means we don't have any duplicates inside our data, and the primary key is unique. So that means the table orders is clean and we don't have any duplicates inside it. Now let's check our database. We have here another table called orders archive. Let's go and check the table. So first, I'm just gonna go and select the data. So select from orders archive. So sales.orders archive. Let's check the results, and here we can see that we have exactly the same structure as the table orders. So now let's go and check whether the data quality is well clean. So now what we're gonna do, we're gonna use exactly the same query as before, but instead of using the table orders, we're gonna take the orders archive. So that's it. Let's go and execute it. So now by checking the data, you can see that we don't have everywhere 1. Sometimes we have 2 rows for the same primary key, which is really bad. So we have here for the order ID 4, we have 2 orders with the same order ID. And as well, for this order ID 6, we have 3 orders. That means those stuff are duplicates and they are against our data model. So now what else we can do is that to generate a list specifically for the data quality issue where we have duplicates. So anything that has 1, we are not interested in it. In order to do that, we're going to use the subquery. So let's say select star from, and then we can use the first query as a subquery. And we're going to say in our filter where the check primary key is higher than 1. So that means I need only the order IDs where we have duplicates. So let's go and execute this. Now I have a list with the primary keys where we have duplicates. So we have the order ID 4 and as well the order ID 6. So guys, as you can see, the window count function is wonderful in order to find data quality issues like the duplicates. Alright guys, so those are the 4 most important use cases in the SQL window function count. So the first one, we can use it in order to do overall analysis, or we can use it in order to do category analysis, like we have done the analysis on the customer behavior. Or another use case, we can use it in order to check the nulls inside our data. And the last use case, we can use it in order to identify or discover the data quality issue duplicates in our data. So now let's go and check the next function. We have the sum. Alright, so now let's understand what is the sum function. It's very simple. It's gonna return the sum of all values within each window. So now let's go and understand how SQL works with this function. Alright, so this is very easy and we are using the same simple example. And now we would like to find the total sales for each product. So we can define it like this: sum of sales, since we are finding the total sales. And then we define the window like this, over partition by products. So as we learned, SQL gonna go first and divide our data into two windows. So one window for the caps and another window for the gloves, right? So now after SQL define the windows, it's gonna go and start aggregating the data. So the sum of sales, that means for the first window we have the 3 sales, and it's gonna go and just simply summarize all those values. So we are adding 20 plus 10 plus 5 and we will get the result 35. So in the outputs we will get everywhere a 35. So that's it for the first window, and as you can see, SQL gonna go aggregate the data within each window separately. So that means as we are aggregating the data for the caps, SQL will not check anything with the gloves, so they are completely separated. So now it's gonna go for the next window, and here we have 2 values and a null. So again here the null will just be ignored. So what we're gonna have 30 plus 70, and the total sales for that's gonna be 100. So as you can see, it is very simple, right? So 100, 100, and so guys, that's it. It's really simple. We don't have here like a lot of special cases like the count function. It's only that it ignores the null in the calculation, and as well the requirement here, it allows only integers, or let's say numbers. So we cannot go and say sum the products, since the products are not numbers, they are characters. So you can only use numbers for the sum function. Let's go now and have some tasks and some use cases in order to practice in SQL. Find the total sales across all orders, and as well find the total sales for each product. And additionally, we have to provide some details like the order ID and the order date. So let's go and do that. Select order ID, order date, and let's get as well the sales. And now we have to find the total sales across all orders. That means we're going to use the window function sum sales, and the definition of the window going to be empty since we don't have to divide the data. So that's it, total sales, and we have to select the table sales orders. So that's it. Let's go and execute it. So with that, as you can see, we got all the details that we need, and as well the total sales, the summarization of all those sales in one field. So with that, we have our overall analysis, one big number for our reporting. We know how much sales we did made in the entire business. So now let's go for the next task. It says total sales for each product. I think you know already what we're gonna do. So sum of sales, and we're gonna do it like this, partition by product ID. So that's it. So we're going to call it sales by products. And with that, we are dividing the data by the product. So let's go and execute it. So as you can see, we don't have the product information. So let's go and add the product ID in the query just in order to analyze the results. So we can see from the data that the winner is the product ID 101. So as you can see, we have here the highest sales if you compare it with the other products, and the lowest one going to be the product ID 105. So as you can see, we can use the window function sum together with the partition by in order to compare stuff, to do comparison between the products in order to understand the performance, for example, of the products. So it's really great analysis for the performance. Alright, now we're gonna move to a very interesting use case for the aggregate functions, not only for the sum, but as well for the others. It is the comparison analysis. Okay, so let's understand quickly what is the comparison use cases. So it's gonna go and compare the current value. For example, let's say we are currently at the month of March, and the sales is 30. So we're going to compare this value, the current sales, with an aggregated value. For example, let's say the total sales using the sum function. So what happens if you compare the current value with the total sales? You are comparing here or doing analysis called part-to-whole analysis, where it's going to help us to understand how important was the sales in this month compared to the total sales. Or we can go and compare it to the best months, to the highest value. For example, the highest value is June, and we can go and compare this month with the best months of the year, or to the lowest month in the year. Or we can go and compare the sales of the current month with the average in order to understand, are we above the typical sales or below the average? And this is very important analysis in order to study and understand the performance of the current data. Alright, let's have an example in order to understand the use case. Find the percentage contribution of each product sales to the total sales. So let's go and solve it step by step. What we're gonna do, we're gonna go and let's select the order ID, and as well, let's take the product ID and the sales, just like this, from sales orders. So let's go and execute it. Okay, so now as you can see in the results, we got the first part of the equation. We have the sales, so nothing like crazy over here. Now we need the total sales over all data. So what we're gonna do, we're gonna have the sum of sales, and the definition gonna be empty. So this is the total sales. Let's go and execute it. So now we have everything for the equation. We have the sales and as well the total sales, and that is enough in order to find the percentage of the contribution. So the calculation for that is going to be very simple. We're going to divide the sales by the total sales. So it's really simple. Let's go and do that. It's going to be the sales divided by the total sales. So we're going to go and copy the whole window function over here, and then we're going to multiply it with 100. So that's it. Let's go and execute it. So now you notice that in the output we got zeros. This is because of the data type. So now if we go to our table over here on the left side, you can see that the orders has the data type of integer. So if you divide integers, you will not get a float or decimal number. You have to go and change the data type. So now what we're going to do, we're going to go and change the data type for one of them. So it's enough for the sales over here. So we're going to use the following statement. So cast sales as float. So that's it. I'm just converting the integer to floats. So that's it. Let me just give it a name. So it's going to be percentage of total. So that's it. Let's go and execute it. So now in the output, you can see we got now the percentage of the total, or let's say percentage of contribution. So now what we're going to do with that, we're going to go around those numbers because we have a lot of decimals. In order to do that, we're going to use the round function like this. Then we're going to have two decimals, and let's go and execute it. So now as you can see, it is really easier to read because we have only two decimals, and we can find immediately that the order rate is the highest contributor to the total. So this is what we call part-to-whole analysis, where we find the percentage of total. It is very common analysis in order to understand the performance of each order compared to the total. So this is an example how the window function is helping us here to compare the current value with an aggregated value. Alright everyone, so that's all for the window function sum. Next we're going to talk about the average function. Alright, so now let's understand what is an average function. As the name says, it's going to find the average of values within each window. So now let's go and understand how SQL works with the average. Alright, so now back to our very simple example, and the task says find the average sales for each product. So it's really easy. We're going to use the average, then pass to it the column sales, and we define the window like this, partition by products. So the first thing that SQL going to go is to define the window. So it's going to divide our data into two partitions, one for the caps and one for the gloves. And now I hope that everyone knows how to calculate the average. So as you know, that it's going to go and summarize all the values and divide it by the number of rows. So it's going to go and summarize 20 plus 10 plus 5 and divide it on 3 rows, and the output going to be 11. So we're going to get it for each row. So as you can see, SQL just ignored everything in the next window. We are focusing only on the caps. Now SQL going to go to the second window and start doing the same aggregations, but here we have the special case of null. So the null is going to be ignored in the calculations, and we're going to have it like this. It's going to say, you know what, 30 plus 70, and we are just including 2 rows. So it's going to be divided by 2, and the average is going to be 50. So we will get the result 50 for each row, and we are completely ignoring the nulls. But now we might be in a scenario where your users understand the business like this. If we find a null in the sales, it means a 0. So there is no sales, and it is actually a 0, but we store it in the database as a null. So that means the average that you have provided is not really correct. We have to divide by 3. So that means first we have to handle the nulls before doing the aggregations, before finding the average. Now we're going to have a whole chapter on how to handle nulls in SQL, what are the different functions, but for now we're going to go with the function qualisk. Okay, so now what we're going to do, we will not use the sales as it is. First, we're going to handle the nulls. So that means we're going to use the qualisk sales and replace it with zeros. So as you can see, we are not using immediately the sales. We are handling it first, and then we're going to find the average. So SQL going to go over here, and if it finds any null, it's going to go and replace it with 0. And that's going to have then an effect on our average over here. So it's going to be 30 plus 7 plus 70, but now plus 0. And now we have 3 rows. So instead of dividing by 2, it's going to go and divide it by 3. And the total result is going to be like this, 33. So that means we're going to have in the output 33 for each row. And with that, we are now fulfilling the expectation from the business. If we have a null, it's going to be handled as 0 and the result going to be more accurate. You see, right? It is very tricky. If you are doing data analysis and aggregations, be very careful with the nulls. Understand them, understand what they mean for the business, handle them correctly in order to get correct results in your analysis. So now let's go back in order to practice SQL using some tasks and use cases. Okay, so let's start with the basics. We have the following task: find the average sales across all orders, and as well find the average sales for each product, and don't forget the details. So now let's go and solve it step by step. So select order ID, order date, and let's get the sales as well, and let's go and find the average sales. So it's going to be a window function, and we have the sales inside it, the usual stuff. The window going to be empty, so average sales, we're going to call it. The table going to be sales orders. So that's it. Let's go and execute it. Oh, we have to select everything, of course. So what SQL did in the output, it's going to go and summarize all those values and then divide it by 10. So with that, we have the average sales of 38. Very easy. So this is again what we call an overall analysis. Let's move to the next one, find the average sales for each product. So again, we're going to go and build the window function like this, average sales over, and we're going to divide it by product ID, and we're going to call it average sales by products. And we're going to go and add the product ID in the query. So that's it. Let's go and execute. And we missed something here. So it is the partition by. Gonna execute again. So with that, we have the following data. So now SQL gonna go and divide the data. So for example, for this product, we have those 4 orders. So what's gonna happen, SQL gonna go and summarize the 4 values and then divide it by 4. That's why we have here 35. The same thing for the next order. It's gonna divide it by 3. And the last one is just gonna divide it by 1. That's why we have 60. So as you can see, the aggregation gonna done separately for each window. And this is as well very nice way in order to compare the averages between the different products. Okay, so now let's have an example in order to learn how to deal with the nulls. Let's say that we have the following task: find the average scores of customers and show as well additional informations like the customer ID and the last name. So let's go and solve this. We are now targeting the table customers. So let's just select it first, like this. And now let's go and include the customer ID and the last name. And let's have as well the score. But this time we're going to go and find the average score. So it's going to be the average score. And since we don't partition the data, we're going to leave the definition like this, and it's gonna be the average score. So that's it. Let's go and execute it. So now as you can see, we have the average score of 625. SQL gonna go and summarize the 4 values and divide it by 4. But here we have a null. So now we have to understand the business or ask about it, what the null means in the scores of the customers. Is it 0 or is it something empty? If it's 0, then the average that we have is wrong because it should be divided by 5 and not 4. So let's say it's 0, that means we have to go and handle the nulls. So what we're gonna do now, we're gonna go and use the function qualis. So qualis, and for the score, and replace the null with 0. So you are the customer score. Let's go and execute this. So now as you can see, if there is a value, it's gonna be exactly the same value, but only if we have a null, it's gonna be replaced with 0. So now let's go and correct the average. I'm just gonna do it like this. So let's go and copy the whole thing, but now instead of using the score, we're going to use the score that is handled with nulls. So I'm just going to go and replace it like this. So here, without nulls. So let's go and execute it. So now as you can see, we are getting more valid result at the output compared to the previous one. And this is only for the case if the null means 0. So guys, as you see, be very careful with the nulls, especially if you are doing aggregations, and handle it correctly before doing any aggregations like the average. All right, moving on to the last use case, we have the comparison analysis, and the task says, find all orders where the sales are higher than the average sales across all orders. So that means we have to go and compare the current sales with the aggregated value, and this time the average of sales. So now let's go and do it step by step. So what we're gonna do, we're gonna go and select, of course, the order ID. What do we need? Let's take the product ID, and we need the current sales. So it's gonna be the sales as it is, and that's it for now. So from sales orders, so that's it. Let's go and execute it. So now by checking the result, you can see that we got the first part of the equation, right? We have the sales for each order. Now we need the second part, the average sales across all orders. In order to do that, we're gonna go and use the window function average sales, and we're gonna use over, since across all orders, that means it's gonna be empty. So let's give it a name, average sales. So let's go and execute it. So now in the output, we got the average sales, so it's gonna be 38. So now we need all the orders that are higher than the average. So as you can see, for example, the order 1 is not higher, but the order 4 is higher than the average. So in order to filter the data, we cannot use the window function in the where clause, right? So what we're gonna do, sadly, we're gonna go and use the subquery. So it's gonna be like this, select star from, and then we're going to define the condition outside the subquery. So it's going to be where the sales is higher than the average sales. So that's it. Let's go and execute it. And now, as you can see, it's very simple. We got all the orders that are higher than the average, right? So you can see all those sales are higher than the average. It would be nice if we can do all those stuff in the first query, but since we cannot do that, we need to use the subqueries in order to filter the data afterward. So with that, we can understand the importance of the comparison analysis. For example, here we are finding or evaluating the data whether they are above the average or below the average, and this is very important in the business analysis. All right, everyone, so that's all for the window function average. Next, we're going to talk about two very interesting functions, the min and max. Alright guys, so what is min and max functions? They are very simple but yet very powerful functions for analytics. So the min simply is the function that's going to return the minimum, or let's say the lowest value within a window, where the max, it's exactly the opposite. It's going to find the maximum value or the highest value within a window. So now let's go and understand how SQL works with these functions. Alright, so now we have the same data and we have two tasks. First, we have to find the lowest sales for each product, and the second one, side by side, we would like to find the highest sales for each product. So we're going to go and use the min max, and as you can see, the syntax is very simple. Min the sales, and then the partition going to be by the products, and here as well the same stuff but having the max. Okay, so now let's see how SQL going to execute the first query. As usual, first it's going to prepare the data, so it's going to split the data into two windows, one for the caps and another one for the gloves, and after that it's going to search for the lowest sales within each window separately. So for the first window we have the following values: 20, 10 and 5, and of course the lowest value going to be the 5, so that's why SQL going to find it over here, and everywhere for this window it's going to be the value 5. So we have it as the lowest sales for the product caps. So now it's going to jump to the next window for the gloves and start searching the values. So as you can see, we have 30, 70 and null. Null will be ignored, so null will not be considered as the lowest value. So SQL going to find the lowest sales with the 30. So it's going to be actually the first row within this window, and the value, the output, going to be 30 for each row. So that's it. It's very simple, right? Now let's move to the next one. We have the same stuff but using max, so the data is partitions, and for the first partition, what is the highest value? It's gonna be the first row, right? The 20. So SQL gonna find it, and in the output we will get the highest sales, 20 for this window, and then it's gonna go to the second window and search for the highest value. So here we have two values, 30 and 70, and it's gonna be the 70, right? So it's gonna point it over here, and in the output we will get everywhere 70. So guys, it's really simple, right? Now let's back to our scenario in the average, where in our business we understand nulls as 0 in the sales. So that means first we have to handle the nulls and replace it with 0, and then we're gonna go and search for the value. So what's gonna happen? We're gonna go and replace nulls with 0. For the max, nothing gonna change. The highest value gonna be 70, and we're gonna get the same output. But for the min, now we have new lowest value. So it's not anymore the 30, it's actually the 0. So SQL gonna go over here and replace the 30 with nulls. So nulls is the lowest sales for the product gloves. So again guys, the nulls are very tricky and those functions are really sensitive with the nulls. Understand what the nulls means and handle it correctly so that you get correct results in the output. So that's it. Let's go back to SQL to have some tasks and use cases in order to practice SQL. Alright everyone, let's start with the basic stuff. Find the highest and lowest sales of all orders and as well find the highest and lowest sales for each product, and we have to provide additional informations. So let's go and solve it. Select order ID, order date, and let's take as well the product ID. Now let's find the highest sales of all orders. It's gonna be the max function for the sales, and the window function gonna be empty since of all orders. So you are the highest sales. Let's go for the lowest sales of all orders. It's gonna be exactly the opposite. The main function for sales over, then we have the lowest sales. So I'm just gonna make it bigger, capital. So let's select the table, sales orders. So I think that's it. Let's have as well the sales actually. Alright, so now let's go and execute it. So now this is very simple, right? This is the whole sales. What is the highest sales? We have the 90 of the order 8. So as you can see, we have now the highest sales, the 90, and the lowest sales is the 10. The first order is the lowest. So it's very easy. Now we're gonna go and repeat the same stuff for the product. So we have go and partition the data by the product ID. So what I'm gonna do, I'm just gonna go and copy paste stuff around. So the first one gonna be partitioned by the product ID. So highest sales by product, and the next one gonna be the same stuff, copy paste by the product. So that's it. Let's go and execute it. So now again, the data gonna be partitioned and divided by the product. So for the first window, what is the highest sales? It's gonna be the 90, and the lowest sales is gonna be the 10. So it's exactly like the overall, right? Now let's go to the second window over here. We can see that the lowest or the highest sales is the 60, the first one, and the lowest this time is 15. And this is great in order to see that the SQL can execute each of those functions for each window separately. So let's go to the last window. It's funny one. So the sales is 60 and we have only one row. So it's going to be the highest and as well the lowest sales. So with that, as you can see, we can define a range for each product, and the ranges are different from each product to another one. For example, for this product 101, the range from 10 until 90, but for the second product, we have it between 15 and 60. Okay guys, let's move to the next one, which is one of my favorites in the window function, where we filter the data using the min-max functions. Let's have the following task. It says, show the employees who have the highest salaries. So this sounds very simple, but we can use the help of window functions in order to solve it. So now we are working with the table employees. Let's just select the data. So select from sales employees. So that's it. Let's go and execute it. So now we have 5 employees and we have those different salaries. Let's go and find the highest salary. So max salary, and let's use the window function over, but we don't partition the data at all. So it's gonna be like this, highest salary. So let's go and execute it. And now by checking the results, we got a new column called highest salary, and inside it we have the 90K. So if you check those 5 salaries, you can see that the highest is from the employee Michael. But still the task is not solved. We have to show only the employees who have the highest salaries. So we have somehow to filter the data and only show this employee. So in order to do that, we have to use the subqueries, since we cannot use the window function in the where clause. So what we're gonna do, select star from, and then our first query gonna be the inner query. So we have the following condition. It's gonna be the salary should be equal to the highest salary. So it's very simple. So with that, we are comparing the salaries with the highest salaries. If there is a match, the data going to be presented. So let's go and execute that. And that's it. As you can see, we got the employee with the highest salary. But if there are like multiple employees with the same salary of 90K, of course, we're going to get it in the results. I think Michael going to need a new job, right?
This is the worst.
So this is another use case for the window functions min-max. Alright, so now we come to the use case of the comparison analysis, where we want to compare the current sales with the highest and the lowest value. So we have the following task. It says, find the deviation of each sales from the minimum and the maximum sales amount. So now as you can see, this is our sales, this is the highest and this is the lowest. So now we just have to go and subtract the data from each others in order to get the deviation. So it's very simple. Let's get the first deviation, where we're gonna go and subtract the sales with the lowest value. So it's gonna be like this. So now what we are doing over here, we are subtracting the sales from the lowest sales of all records. So we're gonna go and call you deviation from min. So let's go and execute it. So now we can see from those values, how far is the current value from the extreme. The extreme here is the lowest value. So this is a really great way to analyze the extremes in your data. So now as we are near to the extreme, the value gonna be low. So as you can see here, we have a 0. This is the lowest because we have it exactly as the extreme. So actually, this is our value, so the 10. Now, the next one is a little bit far away from the extreme, which is 15. So we have it here as a 5. So this is not far away from our extreme value. And then if you check this value over here, we have it 80. So the distance is very far away from our extreme value, the lowest sales. So this is really nice analysis in order to analyze and evaluate the sales of your data. Now, of course, we can go and evaluate our data with another extreme, which is the highest sales. So in order to do that, so we're gonna first say, let's get the highest, the highest sales and subtract it from the sales. So you are the deviation from the max. So let's go and execute it. So now we can see in the output, we're going to get exactly the opposite distances. So the order number 1 is the farthest from the extreme. So as you can see, we have the value of 80 and the order 8 is the identical one. So that's why we have the distance of 0. So now we can see as well very quickly which data points are the nearest to the extreme, to the highest sales. So as you can see, guys, using the window function min and max, it is very powerful in order to understand and evaluate your data points to the extremes. Alright everyone, so now we're going to focus on very important use case. One of the must-know use cases for data aggregations is doing running total and rolling total. These two concepts are very important for data analysis and doing reporting that you must know. The key use case for those two concepts is to do tracking. For example, we can go and track the current total sales with the target sales in our business, and as well it's great in order to do historical analysis for the trends. Okay, so now the question is, what is running and rolling total? They are basically very similar. They're gonna go and aggregate a sequence of members, and the aggregation gonna get updated each time we add a new member to the sequence. A sequence could be like a time sequence. That's why we call this type and analyzes over time. So now we still have the question, what is the difference between the running and the rolling totals? The running total can go and aggregate everything from the beginning until the current data point without dropping off any old data. Where on the other hand, in the rolling total, it's gonna go and focus on a specific time window, like the last 30 days or the last 2 months. And each time we add a new member or a new data point to the window, we will be dropping off the oldest data point in the window. And with this, we're gonna get the effect of rolling, or let's say shifting window. Okay, I totally understand if this might be complicated. Now let's go and have a very simple example in order to understand this concept and as well how we can solve it using SQL. Alright guys, so now we have a very simple example. We have the months and sales, and we have it twice because I want to show you side by side how SQL works with the running total and the rolling total. So now what is the task on the left side? We want to find the running total of sales for each month, and on the right side we would like to find 3-month rolling total of the sales for each month. So they sound very similar, but on the right side we have only fixed window. So now how we can solve this using SQL? On the left side we can use sum of sales. So we want to go and aggregate all the sales using the sum function, and the definition for the window gonna be like this: order by month. And of course you can go and do anything, like you can have here an average, and if you use an average with order by, you will get the running average or the running max or the running count and so on. So that means always if you go and mix an aggregate function together with an order by, you will generate an effect of running total. Now on the right side we're gonna have the same stuff. So we're gonna have an aggregate function together with order by, so sum of sales, order by month. So far we have everything like the left side, right? But now you might ask, why is SQL gonna go and generate this effect, the running total? We didn't here specify like crazy stuff, right? It's all about the definition of the frame clause. So now do you remember, if you use an order by and you don't specify a frame clause, you will get like hidden or let's say default frame clause, and it's gonna look like this: rows between unbounded preceding and current row. And what was the definition of the running total? It's gonna go and aggregate all the data data from the very first beginning, well, the unbounded preceding, until the current position, the current row, without dropping off any old members. So that means the definition of the running total gonna be the exact definition of the default frame clause. That's why SQL gonna go and generate the effect of the running total. Now let's go to the right side, the rolling total. Here again we have the same stuff, right? We're gonna go and aggregate the data using the sum function, and we're gonna go and sort the data order by month. So with that we are as well generating the effect of running total. So each time you use order by with aggregate function. So now in the running total we want always to specify a frame. So here in this example 3 months. So that means if we are getting a new month, we don't want to include the latest months. We want always to be fixed window. Now in order to have this fixed window effect, we have to go and redefine the frame clause, because if you leave it as a default like the running total, the frame gonna keep extending. You will see this effect in the example. So now we define it like this: rows between 2 preceding and current row. So the total number of rows gonna be included in each window gonna be maximum of 3 months. So now I know you might think, Para, what you are talking about? You didn't get anything. It's totally normal. You will understand it only with an example. So in order to do this, let's start with the left side. So first, SQL gonna go and sort the data. So everything is sorted from the smallest month until the highest one. So from January until July, everything is good. And now SQL gonna go and start working with the frame. So the frame says unbounded preceding. So this is gonna be static. It's gonna be always pointing to January. This is the unbounded preceding, the first row in the dataset. And now, of course, we are starting from top to bottom. The current row gonna be pointing as well to January. So the frame gonna look like this. It's gonna be only 1 row. And the total sale of this row gonna be 20. So that's why we're gonna have in the output 20. So now let's move to the right side. The current row gonna be as well January. And what is it, the 2 preceding? We don't have it yet, so it's gonna be pointing maybe somewhere here before the table. So again, what is the frame? It's gonna be as well 1 row. So in the output, we will get exactly the same result, 20. So far there is no differences between the running total and the rolling total. But let's keep going. Now we're gonna go to the next row over here. So what's gonna happen to our frame? It's gonna go and extend, right? So we're gonna have now 2 months in this frame. And what is the total sales over here? It's gonna be 30. So we added a new member. You can calculate it like this: either go and calculate all the sales within the frame, or you can go and say this is the previous aggregated value plus the new member. So the previous one was 20, the new member is 10, we will get 30. Both of them is correct. So now let's move to the right side. What's gonna happen? We're gonna be as well at February. The 2 preceding is still like pointing somewhere outside. And here the window gonna go and extend like this. We have 2 months. And the same aggregation can happen, so we have 30. So far, nothing crazy, right? Let's go to the next month, March. The frame gonna be extended, so we have now 3 months. And the aggregation gonna be either here, 60 or 30 plus 30. We will get the running total of 60. And now on the right side, what's gonna happen? We're gonna point as well to March. And this time, the 2 preceding gonna be pointing to January. And this is the first time we are getting the whole fixed frame, right? So we have here 3 months in this frame. So what is the total of that? It's gonna be 60. Okay, so now you say, okay, we're still getting the same results. So there's no difference. I'm gonna say, wait for it. It's gonna be the next one. So as we go to April, the effect here is that the frame gonna get extended to 4 months, because always we start from the first month until the current month without dropping any member outside. So what is the total of this? It's gonna be 65. Sorry, like this. So now on the right side, what's gonna happen? We're gonna go and add a new member, the April, but we are at the maximum size of the window. We have only 3, and that's because the 2 preceding gonna shift as well down over here. So the boundary gonna be from February until April, and with that we are dropping off January. And now you're gonna see the effect. It is sliding, it is rolling or shifting from top to bottom. And that's because the boundaries as well shifting. So you can see now the effect of the rolling total. The newest member gonna be added, the oldest member gonna be out. We are allowed only to have 3 months. So what is the total of this? It's gonna be 45. So this times we are not aggregating this value, the 60, together with the 5. We are aggregating the values within the window. So now let's keep going. Now we are at June. what can happen on the left side? The frame gonna get bigger. And with that, we will get the result of 135. So the frame is getting really bigger, but on the right side, it's gonna have a fixed frame. So we are just sliding, shifting, and rolling. So with that, we are adding a new member. Another member is leaving, the oldest one, and the total over here gonna be 105. And now we're gonna go to the last row. We will have everything for the running total. So the whole data set's gonna be aggregated. So this is the maximum what we're gonna get. It's gonna be around 175. But on the right side, it's just gonna keep shifting until we reach the last record. The window, the frame, gonna be as well shifting like this. So the total of this gonna be 105. Okay guys, so you see, it's very simple. The running total, it's always consider everything from the starting position until the current row without dropping any member. The rolling total, it's always drop the oldest member in order to add something new, and the window is keep shifting. So the running total is very great in order to do tracking, like for example budget tracking, or we track for example the current total sales with a target or something like that. So always we are considering the whole data sets, but with the rolling total we always do here focused analysis. We are always interested with the window of 3 months. So they might sound very similar, but they have completely different scope for analysis. But both of them are doing aggregations over time. So they're going to help us to do analysis over time, like checking whether our business is growing over time or declining. So guys, as you can see, using very simple SQLs, using the window functions, we can do really great analysis on our data. So those stuff are really fundamental of data analysis or doing reporting for our business. So window functions are really powerful for data analytics. Okay, so now we have the following task and it says calculate the moving average of sales for each product over the time. So now we have here something called moving average. It is very similar to the running total. In the running total we used count and sum and so on, but here we're gonna go and use the function average, and instead of calling it running average, we call it moving average. So let's go and solve the task. Let's start always by selecting the usual stuff. So let's get the order ID, let's get the product ID, and I would say since it's over the time, I will get the order date as well, and the last one, the sales. From our table, sales, orders. So that's it. Let's go and execute it. So now we got our 10 orders with the products, order date, and sales. Let's start building our window function step by step. So which function do we need? We need the average. This is the easiest one. It says moving average. So that's it. We need the sales. So it's going to be the average of sales. Let's go and define the window. So now do we have to divide the data, partition the data? Well, yes, it says for each product. That means we're going to go and use the partition by clause by the product ID. So now I would say that's it for the first step. So average by product. So let's go and execute it. So now if you check the result, you can see that we got our windows. So the first one for the product 101, and the total average of the sales gonna be 35. So we have like aggregated one value for each window, the same thing for the next product and for the next and so on. So we don't have any progress over time or something like moving average over the time, right? We don't have this effect. We have just one average for each window. So now in order to have the effect of the moving average, it's going to be like the running total, we have to use the aggregate function together with the order by. So I'm just going to make it in the new column. I'm just going to copy everything like here. And now what we're going to do, order by. And since it's over the time, we're going to go and use the order dates. Order date, and we're gonna have it as ascending because it's overtime. Overtime always like start with the earliest date and up with the latest dates. So from the lowest to the highest, we're gonna leave it like this. So let's call it moving average. So now let's go and execute it, and we got here an extra comma because of the copy paste. So let's execute it again. All right, so now let's check the results. Let's take the first window over here, and you can see we have on the moving average like a progress. So it starts with 10, 15, 14, 35. So there is like moving average. We don't have one solid number for the average, we have different values. So now how is SQL gonna solve this? It's really simple. It's gonna start row by row. So the first row, what is the average of 10? It's gonna be 10. Then moving on to the next one, it's gonna be 10 plus 20 divided by 2, you will get 15. So now moving to the third one, all those three values gonna be summarized, divided by 3, you will get 40. And now to the last row in the window, it's gonna be summarizing all those 4 values divided by 4, and you will get 35. And this is exactly the same value in the previous column. You have here the average by products. We don't have order by. You got as well 35, exactly like this last row, and that's because we have the same calculation. It is summarizing all those 4 values, dividing it by 4. But now it's interesting, the next value. So as you can see, the next value, it comes from another window. So you see here we have 15 for the product 102, but the average is going to be as well 15. So SQL is not considering the old values from the other window. So SQL gonna calculate each window separately. So it's again here, this is the first value of this window, 15, the average 15, then the same stuff, right? So summarizing those values divided by 2 and so on. And this we call in data analysis, this last field over here, we call it a moving average, and you can implement it very simply using an average function together with the order by. Alright, let's move to the next task, and it says calculate the moving average of sales for each product over time, including only the next order. So as you can see, the first part we have already done is right. We have the moving average and divided by partition by for the products, but here we have more specifications. It says including only the next order. That means we are talking about the current order and as well the next order. So here we have like a fixed frame or fixed window. So we don't need the whole average of the window. We need only maximum 2 orders in each calculation. So how are we gonna do that? We can have our custom frame clause inside our window function. So that means we cannot leave it as a default. We have to specify it. So let's go and do that. I will just copy the old definition of the window because we have the exact stuff. So we have the average sales over partition by product ID, order by date. So this is the first part. So now we would like to have this fixed window. So we're gonna go now and define our frame clause. I'm just gonna zoom out a little bit. It's gonna be rows between. So we have now the boundaries of the frame. It says including the next order. So we're gonna go and use the following. So the first boundary gonna be the current row, and since it's next order, so it's gonna be 1 following. So that is our frame, including only the next order, and we have it like this, 1 following. Let's call it, rolling average. So that's it. Let's go and execute. So now let's go and check the result. You can see the moving average has completely different values as the rolling average. So let's go and understand why. We're gonna do it row by row. Let's take the first row over here. So the sales here is 10. And the rolling average is 15. So why is that? Because in the calculation we are considering the next value. So 10 plus 20 divided by 2, you will get 15. So that means the SQL defined the frame like this, those 2 rows for this calculation for the first row. So now moving on to the second row, SQL gonna include as well the third one, right? The next one. But since the window is only 2 orders, it's gonna go and drop the first row. So the next frame gonna be like this, and as you can see, it's gonna be 20 plus 19 divided by 2, you will get 55. So now you can see the effect of the rolling average, right? So now for the next one, gonna be exact same. So we are at the third row, it's gonna go and include the next one, and we're gonna get the same value because 19 plus 20 divided by 2, you will get 55. Now interesting to the last row in the window over here, it will not go and consider the next value because it is outside of the window. So it's gonna be 20 and it's gonna stay as well 20. So that's it. Alright guys, so with that we have learned about the moving average, the rolling average, and those amazing concepts using the window function. Alright, now we can have a quick overview of the different use cases in the aggregate functions and how the definition of the window gonna change the whole use case. So now the first use case is finding the overall total, and here if you don't define anything in the window, if you leave it empty, what can happen? You are doing here overall analysis. So you're gonna go and aggregate the whole data sets and then provide this aggregation for each row. So this is what happens if you leave it empty, you don't define anything, you are aggregating the whole data sets. Now moving to the next step, we can do analysis called total pair groups. So what we're gonna do, we will add partition by to the definition of the window. So by adding, for example, here partition by products, what can happen? The data going to be splitted into two categories or two groups, and the aggregation going to be done for each window separately. This is of course a great analysis in order to go and compare different products, like here the caps and gloves. So this is helpful in order to compare categories. So you can do this analysis total pair groups if you use the partition by. Now if you go and use the order by, you're going to land in the third use case. As we learned, we will be doing running total. So as you can see here in the output, we are building a cumulative value for the sales, and this is going to help us in order to do progress over time analysis in order to understand the performance of our business. And now moving on to the last use case, the final phase of the window function with the aggregation. Here you have the aggregate function together with the order by with customized fixed window. And of course, we can use it in order to help us building progress over time in specific fixed window. And of course, you can use those use cases. You will get the same effect if you use the other functions, not only the sum. You can use average, count, max, min, so all aggregate functions. So guys, as you can see, the window function in SQL is very important in order to do data analytics. By just like changing the part of the window, you are generating a whole new use case for data analytics. Alright friends, so now let's do a quick recap about the window aggregate functions. So what they do, they're gonna go and aggregate a set of values and return a single aggregated value for each row. So it's very similar to the group by, but here we don't lose details. Now to the next point, what are the rules for the syntax? About the expressions, they all expect a number in the expression. So you have to pass a number like sales or any integer, but only for the count, you can go and use any data type. And the things for the aggregate functions are very simple. Everything is optional inside the definition of the over clause or the definition of the window. So you can go and use partition by, order by, frames or not, or just leave everything empty. So everything is optional. So now as we learned, we have a lot of use cases for the aggregate functions and they are really amazing for analytics. So the first one, the simplest one, you can do overall analysis if you just leave the window function empty. So you will get one big number about your business. And the next use case, we can do total pair groups analysis. As you learned, we can use partition by in order to compare categories with each others, like comparing the products or customers and so on. Moving on to the next one, we can do part to whole analysis. We can go and compare the performance of each data point with the overall. So you can, for example, compare the sales to the total sales in the window or to the all data sets. And we have many comparison analyses. We can go and compare the current value with the average, or we can compare them to the extreme, to the highest sales, to the lowest sales, and so on. And another use case, we can go and identify data quality issues in our data. So we can go, for example, and identify duplicates using the count function. Moving on to the next use case, we have the outlier detection. We can go and find out which data points are above the average and below the average and so on. Then the next one, we have the running total. As we learned, it is a great tool in order to track the progress or to monitor the performance of our business over the time. Or if you want to be more specific, you can go and use the rolling total in order to have like a specific window and only track this window like 3 months or something like that. And the last use case, we can go and calculate the moving average of our data. So it's really amazing how order by and aggregate functions can open for you a door for amazing or advanced analyzers. So guys, as you can see, we have a lot of use cases for the window aggregate functions in the world of data analytics. Alright, so with that you have learned how to aggregate your data using 4 different SQL window functions and their use cases. Moving on to the next one, we're going to learn how to rank your data using 6 different SQL window functions. So as usual, we're going to do a deep dive into the syntax, how SQL works, and the different use cases. They are amazing for data analytics. If you like this video and you want me to create more content like this, I'm gonna really appreciate it if you support the channel by subscribing, liking, sharing, commenting. All those stuff gonna help the channel with the YouTube algorithm, and as well my content gonna reach the others. So thank you so much for watching, and I will see you in the next tutorial. Bye.